The 9-member Southwest Water Authority is planning a dam on the Gila River in Arizona. I've never been to Arizona. Actually, the furthest west I've ever been is Chicago from Indiana. Anyway, seats on the authority will be assigned according to the number of customers in each state that will use the water from the project. There are 54,000 customers in California, 46,000 in Arizona, and 44,000 in Nevada. Use the Webster method. Dun, dun, dun. Okay. Use the Webster method to assign the seats on the authority. All right. Webster. Well, first things first, I have to add all this crap up. So I've got, and I'm going to color code this once again. Let's go with, how about pink this time? There are 54,000 customers in California, and there are 46,000 in Arizona, and there are 44 in Nevada. So let's start by adding the 54,000 plus the, where's my blue pen? Here's my blue pen. Plus the 46,000 and add that to the 44,000 because you have to have the total number of customers, right? And you're going to add all that up, and where is it? You're going to divide that by the 9-member Southwestern blah blah blah. So it's going to be divided by 9. This will be your standard divisor. It's the total population divided by the number of seats that you're going to apportion. And when I add all that up, it's actually 144,000 divided by 9. And that is exactly 16,000. Okay, that's step 1. So now I'm going to take my California customers, and I need to find the standard quota for California. Isn't California CA, I think? CA. I can just use C. C is for California because A is Arizona and N is Nevada. So there you go. I'm not getting into, mailing things. Okay, so we're going to take the 54,000 here and divide it by 16,000. And that comes out to be, now I only need to go out a few places, so I'm just going to go out to the nearest hundredth because remember, you're going to have to use standard rounding rules for Webster, and you're always going to be rounding to either the lower quota or the upper quota, so that's a whole number. So I really just need the tenths position, but I took it out 2 places. And so according to Webster, if he looks at, well, let me do the other ones and then I'll do the rounding. So let me do Arizona next. The standard quota for Arizona would be 46,000 divided by 16,000. And that's a 0. And taking that out 2 places, I got 2.87. And then let's do Nevada. The standard quota for Nevada would be their population of 44,000 divided by the standard divisor, because I'm dividing by that number. And out 2 places on that, I got 2.75. Okay. So now I'm going to go back to an orange pen because we're doing Webster, the Webster method, and he just uses standard rounding rules. So he's going to round to the nearest whole number based on the number in the tenths position. So 3.37, he's going to give California, wrong color, April. He's going to give California 3 seats because 3.37 would round down to 3 holes. he's going to give them 3 seats. And then he's going to give Arizona, again, he's going to round to the nearest whole number. So he's either going to give them 2 seats or 3 seats, but it depends on this. Since that's an 8, which is bigger than 5, he's more than halfway there. If you're between 2 and 3, halfway would be 2.5. He's at 2.8. He's beyond halfway. So he's going to round up to 3. Sorry, wrong color. He's going to round them up to 3. And then he has to figure out, well, what am I going to give Nevada? And Nevada is a 2.75. So they're going to get either 2 or 3. When he looks at this number, 2.7 is more than halfway between 2 and 3. So he's going to give them, he's going to round them up to 3. And when I go back and add these, 3 plus 3 plus 3 does add up to the 9. Boom, I'm done. I've assigned them. I think my math lab has little boxes saying, you know, how many seats will California get? 3. How many seats will Arizona get? 3. How many seats will Nevada get? 3. And you're done. I did not have to do any modifying on this. But if this had not added up to 9, then I would have gone back and either made my, if that had only been, let's say 8, that means I would have needed one of these numbers to get bigger, which means what I'm dividing by would have to get smaller. So I would have picked something less than 16,000, like 15,800 or something. So, and again, you're just randomly picking numbers on that. But I didn't have to do that here, so yay!